We are starting module 9 now. So we have been spending a lot of time talking about expressions. So expressions are the problem. What do you need to do? So now we're going to take that knowledge and we're going to start making equations with those expressions. So an equation is just two expressions that equal each other. They're the same on both sides. So we are going to today work on writing and solving equations using all four operations. So if you have not already tried today's Spark about Bella and Tia beginning the week with the same amount of money, will you please go ahead and do that? And then come back and see how I thought about it. So Bella and Tia started the week with the same amount of money. So that's important to know. They started with the same. Bella paid $9 to go to the movies. Tia spent $2 on snacks and $7 on a new shirt. Do Bella and Tia have the same amount of money left? Explain how we know. So one thing I can do is I can just draw this bar to represent Bella. And I can draw that exact same bar to represent Tia because they started with the same amount of money. So even though we don't know what that amount is, we know it was the same. So I know that Bella paid, let's say $9 is here. So she paid $9 to go to the movies. So this is what Bella has left. So I know that Tia spent $2 on snacks and $7 on a new t-shirt, and 2 plus 7 is 9. So I can see they spent the same amount of money. I can see they also have the same amount of money left because they started with the same amount. So let's write an expression to show how much money each girl has left if they both started with X amount of money at the beginning of the week. So we want to write something to show how much they have left. So we're going to use X as our starting amount. So this whole thing is X. So we have X, and then Bella spent 9. So X minus 9 would tell us the amount that Bella has left over. And on this one, we start with Tia. This is what she has. She started with X. Then she spent $2 on snacks. We want to minus $2. And then she spent $7 on snacks. We want to minus 7. So we can see now we minus 2 minus 7 is actually minus 9. These are the same equations because I can combine these terms here. So if I have this number line and I'm here at 0 and she spends -2 and then -7 more, 1, 2, 3, 4, 5, 6, 7. This is also X minus 9 when we combine like terms. Okay, let's go ahead and head over to task 1 when you have finished all of your Spark questions. So we can think of an equation as a balance scale. So when equations happen, so when equations are true, they're the same on both sides and your balance would be perfectly straight and level. So this scale shows two quantities that have equal weight. So we can see that this is balanced. So even though they don't have the same thing on both sides, their values end up being the same. So an equation is a mathematical sentence that shows two expressions are equivalent. So we have an expression on this side, we have an expression on this side, and this is saying they are equal. So equations have that equal sign. So two expressions that are equal. So I want you to think about what is the difference between an expression and an equation. So take a second and think about that. So an expression is just the problem. So if I have 4 plus 3, that's what I'm doing. I have 4 apples and I got 3 more, 4 and 3 more. I can also say that that is equal to 7. Another expression is just 7. I have 7 apples. These, and now I can turn it into an equation by putting an equal sign. So this is an expression. This is an expression. These two expressions have the same value. So together with the equal sign, they make an equation. So we want to write an expression to represent the left side of the scale. So what two terms do we have here? So we have 2 and we also have 5. And what do you think they're doing with those? So we know that these are balanced. So if we multiply them, that would be 10 and this would be heavier. So what operation can we do to balance this? So we need to add these. They're just placing them. We have 2 and they put 5 more on. We're just adding on to what we already have. So now we want to write NX. So we have a unit of 2, we have a unit of 5. Together they make 7. So now we want to write that expression for the right side of the scale. So we just have this one term here. So they just placed 1 unit of 7 on here. So this one has a unit of 2 and a unit of 5 together. This one just has 1 unit of 7. So now that we have both of our expressions, we can go ahead and make those into an equation. So now we want to write this equation to represent what this scale is showing us. So see if you can write that expression. So on the left side, we had a unit of 2 and a unit of 5. The term 2 and 5 added together equals the expression of 7. 2 plus 5, we can combine those like terms. 7 equals 7. They should be the same on both sides. So what do you think would happen if the 2 were taken away? So let's take this here and remove our 2. So what's going to happen to the scale? So think about that for a second. So this scale now is not balanced. So which side is heavier? The 7 is heavier, so the 7 is actually going to tip down more than the 5. The 5 will go up because it weighs less. The 7 will go down. So if the 2 were taken away, we would no longer have any balanced equation. So our equation would not be true if we took something away. So go ahead and complete everything on task 1. And then when you are ready, come back and let's do task 2. So task 2 tells us we have this scale here. So we can see we have a unit of 4 and a unit of 5 more. Over here we have 6 and then we have another value, but we do not know this. So they just replaced it with a variable. But we can still figure out what that is without being told. So we can see that this is level, so we know these equal each other. So first I want you to write an expression for the left side. So go ahead and try that. So we have a unit of 4, and then they added on a unit of 5 more. So now what do you think will represent the right side here? So we have a unit of 6, and then they added on a unit of an unknown value. We'll just call that x. So now we want to write that out as an equation. So show how these are balanced. So we know that 4 plus 5 equals 6 plus x because we can see that they are balanced here. So they can equal each other. So now I want you to think about how can we figure out what x is? So I know that I can combine these terms on this side. We still, when you are doing this, have to follow our order of operations. This one doesn't have any groups. It doesn't have any exponents. It doesn't have any multiply or divide. So we can just put these together. You still have to follow that order of operations. So over here, we know that this side is 9. So we need to think about 6 plus what is going to equal 9. So these ones that are smaller numbers are fairly easy to do in our heads. I know if I'm at 6, I can add on 7, 8, 9, which is 3 more units. So I can figure out that x equals 3. So when they're fairly small numbers, they're pretty easy to do in our heads. But I want to talk about what we'll be getting into for just a second here. So I know that 4 plus 5 is 9, so I can do that and combine those. But I can't put 6 and x together because they are not like terms. This is a number, this is a variable, they're not the same. So I want to do the opposite of this, and I want to get x all by itself. So this is a positive 6 here because it doesn't have anything in front of it. So the opposite of positive 6 is to do negative 6. Negative 6 or positive 6 minus 6 just ends up being 0. So it canceled out. So it's gone on this side. But what we do to one side, we have to do to the other to keep our equation balanced. So do it to one side, do it to the other. Otherwise, if I just take away 6 here, that means this side's going to go down more. So I also have to take away 6 on this side to keep it balanced. So if I take away 6 from this side, I'm left with x equals 3. I'm left with 3. And the only thing I have left on this side over here is x. 3 equals x. X equals 3. So I know it's pretty easy to look at these now and say, yes, oh, this is 9. 6 plus what is 9? But we're going to be getting into some harder problems. So I just want us to start thinking about how we'll be doing these. So I also want you to think about the question, are there any other values of x that would keep the scale balanced? So if I replace x with a different value, would it be balanced? So let's say I replace x with a 4. What happens? We know this side is 9, makes this side 10, so they would not be balanced. So going bigger doesn't help. What if we go smaller? Let's try replacing x with 2. So this side is still 9, but this side is 8. So now this side would be bigger and they are not balanced. So that doesn't work. What if we try really close to 3, 2.9? So this side is still 9. If I have 6 and 2 more, that's 8.9. So they are super, super close to each other, but they are still not balanced. So for this particular equation, there is not another value of x that will keep it balanced. Any other value is going to either make it less or more than the other side, so it won't be balanced. So go ahead and complete task 2. And then when you are ready to do task 3, come on back. Hey, task 3 tells us that Ben is buying tickets for the outdoor skating rink as shown here. So here is what Ben has done. He bought 4 tickets and the total was $72. So 4 tickets were $72, not $72 for each ticket. That would be pretty crazy. So each ticket costs the same amount. So no matter who is skating, they had to pay the same amount. And we want to know how much one ticket costs. So first, let's figure out and write down, what do we know? So how many tickets did Ben buy? So he bought 4 tickets. And we know the total was $72. We also know that each ticket was the same amount. So we're doing the same thing over and over and over again. So here's our total of 72. And we know that they're taking that and they bought 4 tickets. So this ticket is the same price as this ticket, same price as this ticket, same price as this ticket. So what do we want to find out? We want to find out the price of one of these tickets. So we want to know the price of one ticket. So using that information, we're going to say that the unknown cost of one ticket is C. So I put T's and they chose for ticket, and they chose to put a C for cost of the ticket. So we can just go switch those out. So these are all C's. We want to know one of these C's here. So how is C and the amount Ben spent related? So let's draw that picture again. So we know our total was 72. This whole box is 72. And we know that he bought 4 equal tickets. So each of these are the cost of a ticket, and altogether they equal 72. So let's think about what are we doing here. So I could do C plus C plus C plus C, but repeated addition is better to do as multiplication. So how many C's do I have? I have 4 of them, 4 C's. So we're taking 4 and we want to multiply that by C. We can't just do 4 plus C. That means $4 plus another ticket. We need 4 tickets. This was like giving them a tip of $4. So adding's not going to work. So we need to take one ticket and times that by 4, and that is going to equal our total of 72. We could also take 72 and we could divide it by 4, and that will equal the cost of a ticket. So we want to take our cost, multiply it by 4, and that will equal 72. We don't want to take a ticket away from 72 one time. We would have to do that 4 times. And that still doesn't help us figure out C because we don't know what C is. The cost of C added to 4. So this is one ticket plus $4. So that's not helpful. And we can't take a ticket and divide it by 4. We would have to take the total and divide it by 4. So this one doesn't match either. So we could divide, but this expression here, this is still not what we want. We want 72 divided by 4, or C times 4. So the only one that makes sense of these words is this first one here. We're taking C, multiplying it 4 times to equal 72. So I want you to complete task 3, just A through D. So when you get to the end here, so task 1, 2, 3. So go ahead and do A, B, C, and D. And when you get to this connect vocabulary box, I want you to come back to the video so we can talk about this next part here. So a solution of an equation is just the value. Solution is when you solve it and it makes it true. So when the value is true, we have found the solution. So let's try substituting C for 20 and see if that's true. So we know we had 4 C's and our total was 72. So if we take 4 and times that by 20, 4 times 2 is 8 with a 0. So that's $80, but they only spent 72. So I know that this is not true. So C does not equal 20 in this case. So we need to figure out what does make C true. So I know that 20 was too big. So we could try 19, then we could try 18, and we could just keep guessing. But that's a lot of guessing and checking. And I like to be very efficient when I do math. I sometimes I call myself a lazy mathematician, but that doesn't mean I don't do the work. It just means I do it in the quickest way possible. So I don't want to sit and guess and check what this C equals. So instead, I want to remove the 4 from both sides. So remember that balance. So right now we've got this scale that's balanced. So on this side, we have 4 C's, and on this side, we have 72, and they're balanced, they're equal. So if I take away the 4 here, then it wouldn't be balanced. We'd have more over here. So I have to remove the 4 from both sides. So this is 4 times C. So we want to do the opposite here. So we're going to divide by 4. 4 divided by 4 is 1. Now I just have 1 C here. We don't need that coefficient of 1 because when we multiply by 1, it's the same thing. 1 times C is still just C. So since we divided by 4 on this side, we have to do the same thing to this side. So we're going to take 72 and divide it by 4, and that is going to tell us what C equals. So C is 72 divided by 4. So I'm going to let you finish that problem, and then you can go and complete tasks E through F. So you can do E and F once you have solved that and know what C equals. So if you have any other questions on this, please be sure to let me know. And then today you're going to do your check for understanding, and then you will also complete your homework. So if you have any questions on any of that, be sure to let me know.